All right, guys, number 13. The length of a rectangle is twice as long as its width. Let's just draw a little picture of what that looks like over here. Here's my rectangle. I don't know what the length or the width are, but I know that my width is the shorter side, and I know that my length is 2 times that shorter side. Which of the following gives the area of the rectangle as a function of its width? Well, the area is just the length times the width, so in this case it's going to be the area is 2w squared. I just multiplied the length times the width, and that is answer C. Is that the only one that works? 2w squared. Yep. Is there anything, I'm just trying to check in if there's any way I could factor anything out and make it the same, but it doesn't look like it. Number 14, I have to make all of the radicals have the same square root, and then I can add and subtract them. Just like over here, if I have 2x and 3x, I have 5x. But if I have 2x and 3y, I can't add those together. They have to stay separate, right? So what I want to do is, let's see if I can erase this easier. What I want to do is change all of those square roots to be square root of the same thing. And I just noticed this is that number sense, and obviously because I've been doing math for more years than I'm going to tell you on this video, I already knew that 3 can go into 27 and 3 can go into 12. So I'm guessing that I'm going to try to get them all something times the square root of 3. Right? So let's start with, and I'm just going to take these piece by piece. I'm going to start with 2 root 27. I'm not going to worry about the subtraction that's happening. All I'm going to tell you guys, if you have 2 root 27, 2 times the square root of 27, that's the same as 2 times the square root of 9 times 3. Right? I haven't changed anything. I have just made 27 look different. And the reason I did that was because although 3 doesn't have a square root and 27 doesn't have a square root, 9 actually does have a square root, right? The square root of 9 is 3, so I can cancel out that 9, and I just put times 3 in the front. So what that does is it changes things. So I'm going to start here. I'm going to keep 3 root 3, but then I'm going to subtract, and this time I'm going to subtract, instead of 2 times root 27, I'm going to subtract 6 times root 3. And just in case you guys don't believe me, let me put up the calculator and let's see if those two things are the same thing, right? So if in the calculadora I put 2 root 27, okay, and I hit enter, and then I put 6 root 3, I get the same exact answer back. So I haven't changed anything. I've just changed the way that it looks. Just like in order to add fractions sometimes, you have to find a common denominator, right? And then over here, instead of 4 root 12, I'm going to put 4 times root. Remember, I want to keep that 3, 4 times 3. Okay, and the square root of 4 is actually 2, so I'm going to cross out 4 and I'm going to put 2, because the square root of 4 is 2, 2 times 4 on the outside, and then instead of adding 4 root 12, I'm going to add 8 root 3, and see what I did there? Now every single term has square root 3, just like x's. Now I can add and subtract those coefficients, right? So actually all I need to do is 3 minus 6 plus 8, so 3 minus 6 is negative 3, plus 8 should be positive 5. This is all in my head, you guys, so please double check me. I'll leave that up to you. I said that became 5 root 3. Don't forget that root 3 is still there, but we're just going to leave it like this, okay? All right. Let's keep going. Whoops. Solve the following. Okay, you guys, if you had trouble with this, I bet you're going to kick yourself because you didn't think it was this easy. But if I have the square root of something right here, I have the square root of 7x minus 11, and it's all underneath that radical, all I'm going to do to get rid of it is square both sides. Or you may remember from last year, take each side to the 1/2 power. But if I square that, all that happens is I get rid of the radicals. So I just have 7x minus 11 equals 0 squared. I have to do both sides, right? But that's just 0. And then finish solving. I'm going to add 11 to both sides, and that becomes positive 11. Then I'm going to divide both sides by 7. And x equals 11 over 7. Okay, boom. So same thing here, but this time, instead of 0 on the other side, I'm going to get 6 squared, which is 36. So I'm going to have 7x minus 11. Oops, let's just assume that that's minus 11 there. It looks like it came up funny here. Is equal to 36. Then if I add 11 to both sides, I get equal to 47. And then divide both sides by 7, and I get x equals 47 over 7, or 7 can go into 47 6 times with 5 left over, 6 and 5/7. Okay, or you can do the decimal. I'm not going to worry about that right now. And this time, this is equal to negative 11, right? So this time when I square both sides, I'm going to get 7x minus 11 is equal to, and it doesn't matter that this side is negative 11, because remember, a negative times a negative is just a positive. So it's equal to positive 121. I add 11 to both sides this time. I get 7x equals 132. Divide both sides by 7, and I'm going to get, well, let's practice some long division here. 132 divided by 7. 7 can go into 13 just once. With 6 left over, 62. 7 can go into 62. 7 times 8 is 48. 7 times 9 is, wait, 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63, I think. So we're going to go 8. And that 7 times 8 is 56. So I'm going to subtract. So that's 4, 5, 6. Okay, so I get a remainder of 6. So I get 18 and 6 over 7, almost 19. Double check that for me, you guys. I'm counting on you. This is all off the top of my head. So 15, 16. Find the area of a rectangle whose sides are the square root, when in doubt, draw it out. That's what I say. The square root of 12. Okay, and the other side, I'm just going to make an area model here. The other side is the square root of 8 plus the square root of 18. Okay, and let's see, is there any way? There is a little bit. I can reduce these things first. That'll be good practice. The square root of 12, remember, is the square root of 4 times 3, which the square root of 4 is just 2, which is 2 root 3. Okay, so instead of the square root of 12, just to make the numbers easier, I'm going to make this side 2 root 3. And here, instead of the square root of 8, I'm going to do the square root of 4 times 2. The square root of 4 is just 2, so I actually have 2 root 2. Okay, so instead of the square root of 8, that's going to be 2 root 2. And the square root of 18, I'm going to do 9 times 2. The square root of 9 is 3, so this is just 3 root 2. Okay, so 3 root 2 instead of the square root of 18. Cool, and now I'm going to just do my area model here. So I have 2 times 2 is 4, and then the square root, and the square root of 3 times the square root of 2 is just going to be the square root of 6, because you can just multiply the insides together. And then the other side, this is just going to be 6 root 6. So the area of this entire rectangle, now I can just add 4 root 6 plus 6 root 6, and I get 10 root 6. And I don't think I can make root 6 any different because 2 and 3 don't have square roots, and neither does 6. But don't just take my word for it. Let's check. Let's check if we just did the square root of 12 times the square root of 8 plus the square root of 18. So the square root of 12, 12 times the square root of 8 plus the square root of 18. If I'm putting all of my parentheses in, and I had to put parentheses around the square root of 8 plus the square root of 18 because you have to add those together first before you multiply there when you do it this way. And I get 24.49. So that would be the area. And then let's put in 10 root 6. Whoops, guess I don't need that. I don't think it will hurt. See? Boom, exactly the same. Now, why are you asking yourself, why did I just do all of this and then watch you put it in the calculator? Because there might be a question like this where it's multiple choice on your SAT and they don't have 24.49 as an answer, right? Approximately. The answer that they're going to have is 10 root 6. And it's pretty basic math. It's just trying to remember those rules. So I know you guys can do it. If you are doing this, you might want to like take some notes in your notebook. Just, hey, I need to remember how to, and it's called simplify radicals. And you might want to write that stuff down really quick, or at least put this here and circle it and ask me to go over it again in class so you can take notes on it. But these are your notes, you guys, and I want you to have all of the supports that you need. Okay. Number 17. Am I going to have time to do this? I'm going to go ahead and stop this video at 16 and start the next one. So I'll start 17 next.